Hello, welcome everybody. We are here in a unique situation. We have, for the first time in IHE's history, I think, a guest lecturer who is offering a free course in our Open Coursera platform. And I can see that we have already 110 people in the live stream. I'm not going to talk much, but I welcome you all. Please use the chat to introduce yourself. And if you have any questions, also put it in the chat. And then later we will give those questions to Saul Montoya from HatariLabs. He's our guest. Later he will be joined by Gabriella, who will also answer questions in the chat. So I'm going to give the floor to Saul Montoya.
Sorry. Hi, do you hear me? I hope that you hear me well. My name is Saul Montoya. I am from HatariLabs. I am a geologist, numerical modeler. We are going to give a course in groundwater modeling. This course is intended for general audience. I mean, this course is intended for people that do know nothing about groundwater modeling, for people that have some knowledge in hydrogeology, and for people that were using another software and they want to switch to this open source software. Okay. I will share my screen, so this is the last time that I actually will see my face. There is a great support over YouTube, so when you have any questions, you can make your questions through YouTube. Gabriela will be supporting and giving answers through YouTube, and I will ask some. This is a new step on the online classes because I want to know how well you are doing. So if you are doing well, I'm going to ask some questions about. If you are at this point, please type yes 1, yes 2, yes 3, or yes 4. Why? Because for me, it's the feedback if you are doing great, or maybe you get lost. Okay, so if I don't receive this feedback, we might have some problems because I can do. I mean, I've been dealing with software more like 15 years with the groundwater software, and I can do things much quicker. So if I don't hear from you, I think that I can do at much faster speed, faster step. Okay, so Hans, if everything is right with the mission, can I start the course?
Yes, so go ahead. Everything is on, and we have 99 people in the live stream, and they're interacting. So go ahead.
Okay, so I will share my screen. Okay, so let's have a review on the. Let's have a review on the objectives of this course. With this course, you will know the Model Muse environment tools for modeling, know the potential of Model Muse to build MODFLOW models, grid design and boundary conditions, and to build and simulate numerical models. Okay, HatariLabs was designed as a website for a consulting company, but later on it turned into a blog. Okay, and in this blog we have a lot of stuff on groundwater modeling, maybe, and it might be like the main repositories of tutorials on MODFLOW. Okay, but these tutorials are applied tutorials, so in this course we will give the basics in order to understand the software, so you can do like kind of tutorial or a case that is close of what you are doing, okay, or your interest. Okay, great. So on the first class, we are going to have a description of Model Muse, the buttons, and so on. However, yeah, there is a tutorial here. There was a tutorial here that is this tutorial to install MODFLOW 6 and Model Muse 4. Yeah, I hope this was on that you have on MODFLOW 6 already on your computer. I hope so. Yeah, and if you have this on your computer, please type yes one. So now we start with these questions. If you have followed this tutorial and then you have MODFLOW 6 and Model Muse 4 on your computer, please type yes one. Okay, yes one. Yes one. The number is really important because we are going to be yes 15 or something like that. So it's really the number. Okay, great. So you are great. In the tutorial, okay, well, let's see the website of Model Muse, but because it's really important to see where everything comes from. Okay. Okay. Material. Okay. Let's go to. Okay. Let's talk about a little bit of Model Muse. Yeah, Model Muse is a graphical user interface. So what does it mean? Graphical user interface is the normal environment where you have buttons to do actions. Okay. In okay, so this similar of what you do in Windows. So you have a button that open a document, you have a button where you can edit, you have a button where you can save. Yeah, this is a graphical user interface. And Model Muse is a graphical interface for groundwater models. Okay, and in Model Muse, you can do and you can work, you can build, you can run, and then you can analyze models that were done not only in MODFLOW, okay? So you can work models in MODFLOW 6, MODFLOW 2005, MODFLOW LGR, MODFLOW LGR2, MODFLOW NWT, MODFLOW CFP, MODFLOW OWHM, MODPACK, some budget, PASS, Sutra, and NT3D, MS, and NT3D. So as you see, there is a lot of model types done by the USGS. Okay, well, this is for you because you will see those options on Model Muse. This course is intended to work with MODFLOW 2005, I guess. Yeah, the work procedure is really similar of what you will do in MODFLOW 6. Okay, and for example, here we have, there is a summary of Model Muse. If you are, I strongly recommend that you work on the 64 operating system. I don't know if any of you have a 32 operating system computer. However, in my experience, I see that there are more bugs on the 32 than on the 64. Okay? Okay, great. So if you have it already, there are some material on the course that are the PDFs, and this is something great about those PDFs because we are going to work with the PDF, so we are not going to do anything that is outside the PDF. Okay, and this is great because if you want to recreate or if you want to come back and see or do it by your own, and this is the topic of doing by your own is really important because what happens on the course is that you on the course everything is perfect. So in everything is uh, everything is great. So you work very well. You do your model, the model converts, you get the results, and so on, and everybody is happy. But when you do by your own, you face a lot of challenge because models are not the same. So you have a model with another boundary condition. You have models with with another challenge on the boundary conditions or in the discretization and so on. Okay, so that's why you need to have like a guidance or say, okay, in the course, what have we done in this step? Okay, this is the step that we have done in the course. Okay, so I will open this and then okay. So as we have said, Model Muse actually works with all of these models. Okay, and well, you have already you have already downloaded and you have already installed it. That's what you have told me. And then we are going to open Model Muse. Okay, so here in your computer, look for Model Muse. Actually, it opens in the other screen. Okay, so here I will open in Model Muse. Okay, okay, and that's it. And then here, this is what is appear. Okay, after I press on this, and maybe you can have it on your desktop. I don't know. No, I don't have it on my desktop. Okay, but if I type Model Muse, actually it appears here. Okay, yeah, it appears here. Okay, and then you have these options. If you are here with me, type yes to. Yes to, please. Okay, great. So I will explain what is here. Okay, what you can do, you can create a new ModFlow model. You can create a completely new model, but you can also create a fast model. What is fast model? A fast model is a transport reaction model that implements another code that is called XT3D, I guess, or maybe I have to check, plus Frixie. Okay, so it's a transport reaction. So this model, it will be required when you have, for example, a contaminant plume, and this contaminant plume is actually degraded, or the contaminant species are being speciated in another chemical compounds. Okay, so when you want to deal with that, I will strongly recommend to do it fast. Okay, so then we have Sutra. What is Sutra? Sutra is an old code as well from the USGS that create finite different model. Okay, finite element model. Okay, so ModFlow. Okay, this is a kind of telenovela, yeah, soap opera, because ModFlow was find a different model, but it was still ModFlow 2005. In ModFlow 6, we have this triangular discrete. We can do triangular discretization in ModFlow, and then we can do Voronoi discretization in ModFlow. Almost any discretization in ModFlow. Okay, that was not possible in ModFlow 2005, but now it's but at the time that where you have of ModFlow 2005, in ModFlow you can create grids, like I mean regular array of rows and columns. While with Sutra you can create triangular grids. Okay, but now in ModFlow 6 you can also do triangular grids. Okay, I hope that you are not get lost. Just well, um, I want to give you as much information as possible, but also if you have any questions, I am I watch the chat, and so I can answer that on the spot. Okay, there is another topic of water well footprint. Well footprint is related of the capture area of of wells. Richard Winston, that is the developer of Model Muse, has a tutorial on well footprint. Actually, I haven't worked in any. But if you see the tutorial of Richard Winston, so you just have to look. Yes, there are some videos on here on Model Muse videos. There is a new one in. Well, it's not new. I well footprint. Well, it's new for 2018. No? So okay, if you are learning it, or if you want to do consulting or research or your master thesis or something, I will strongly recommend as well to watch these videos, okay? Because these videos are really, really important if you want to know more about the software. I have watched almost all of them, okay? Almost all of them. Yeah. Yes. Okay, so everybody create a new MODFLOW model and type next. Okay. Mhm. Okay, so if you are here, yeah, here this screen is almost how can I how can we tell you, this screen is informative only, okay? And and I hope that you are here with me because otherwise I can be like very okay. Let's talk about the spatial temporal topic of model with MODFLOW and Model Muse. Okay. Oh. If you work in MODFLOW actually do not care where the model is located because what MODFLOW will care is about the grid and the position of one object in the grid. Okay, great. This is the first thing that you have to remember. Okay, so the model actually, for the model, a coordinate system is a coordinate system that can allow you to put any object in the grid. Okay, great. But however, what will happen if you, for example, have to do a repository of your model, and then any person 5 years from here to 5 years have to know where the model is located. Okay, because for example something happened and then a guy only found a file that say model one, and then the guy say, "Oh, where is this? Where is this model located?" Okay, I don't know. I mean, it appears a basin, but I don't know which basin refers to. Okay, so that's why here you can put some metadata regarding to the system of projections. So with this system of projections, a future user or like a colleague can locate exactly where your model is located. So it can work with EPSG on project Pro 4, but you can type, for example, here in Peru, we are in 2, this is our EPSG code, okay, 32718, so it means 32, that is WGS UTM, 7 because we are in the south hemisphere, and 18 because we are in the zone 18. Yeah, but this is only declarative. I mean, actually, you are not required to do. You are not required to do the more during the simulation. This data won't be used in any part of the simulation, or yeah, this is just to provide the right metadata for right interoperability of the model. Okay, great. If you are here with me, type yes3. If you have any questions, you can drop your questions anytime as well. Okay, great. So you say you can put, but as well, this is only declarative. So example of class 1. Okay, the starting time is as well declarative. Okay, and then you have the length units and the time units. Okay, from all of these are the two that they will be used on your numerical simulation. These only two will be used on the numerical simulation. You can work with meters or feet. Yeah, since the code is done in the US, they always have this imperial, I think, system unit that they work with feet. For us, I would strongly recommend that you use meter, the international system, where the unit of length is meter. And for time unit, you have seconds, minutes, days, and years. And this, I'm kind of more flexible here. Why? Okay. Um, okay. There is a okay. There is a good question from Naga that say, how do we know the projection code for a present location? This is great because you have to know your UTM and your system of projection, and I guess well, can it really depends on your uh, yeah, it really depends on your on the country that you are. Maybe we can later on we can provide you some links regarding that. Okay. Okay. So okay. Sometimes transmissivity is being reported in meters per day. Okay. Or like hydraulic conductivity is reported in meters per day. That is great. I mean, however, I use meters per second, and it's really up to you to select which is your time unit. Because if you work with days, you will have it will be easier to work like transient simulation over 3 years, 5 years, 6 years, so because you will have a number of days, or maybe even you can work with years. What is my recommendation? Um, and please know that if you are taking notes, that if you select any type of length unit and any type of time unit, you have to translate all your data to those units. Okay? You have to translate all your data to those units. For example, you select the time unit to days, all your transmissivity, all your hydraulic conductivity has to be translated to this unit, because I think later on there were some options to translate in Model Muse, but it's not a great quality practice. Okay, so for me, as a modeler, I always translate everything to the units that I have selected to do the model, and then I start to do the model, because later on you will have values and then you don't know if those values were, I mean, you can get the value, but you don't know which was the time unit or the main unit of that value. Okay, but for example, if I work in meters and second, I know that all the all the parameters that I have are expressed in meters, second, square meters divided by second, and so on. Okay, so in this case, it's meters and second, and as a my advice, if you select a length unit, a time unit, translate all your information to those units. Okay, next. First, great. Are we here? If we are here, type yes 3. Yes 4. Yes 4. Okay, great. Here we are in MODFLOW 6. Okay. Then we can also select the MODFLOW 2005. We can also select the MODFLOW NWT. We can also select the MODFLOW OWHM. We can also select CFP or LGR. Okay. Let's have a review of what those mean. Okay, MODFLOW 6 is the latest version of MODFLOW because it's the sixth version of MODFLOW. Okay, so MODFLOW, the first version was on the 88, then it comes 96, then it comes 2000, then it comes 2005, or maybe I'm missing some. Okay, so MODFLOW 6 is the latest version of MODFLOW. And some of the tools of MODFLOW 6 are available in Model Muse, because Model Muse actually do not implement the unstructured grid yet. Okay? Then we have MODFLOW 2005. Okay? MODFLOW 2005 is only on finite different methods. So I mean, in MODFLOW 2005, you can create regular grids of row and columns like this one. Okay. However, for example, what happens to me is that if I wanted to do regional modeling, I mean on the scale of basic modeling, I will on complex geometries, I could not reach the solution with MODFLOW 2005 because the matrix was kind of very intense non-diagonal. They have a number because it was the solver could not have a solution for the model. That's why it came MODFLOW NWT. MODFLOW NWT is a Newtonian solver, Newton-Raphson solver of the groundwater flow that is more flexible with complex geometries, is more flexible with dry cells, and it is and with I think that it is more flexible with great changes on hydraulic properties. So I mean, if you have a K of 10 to the minus 5 close to a K of 10 to the minus 3, you have two orders of magnitude from one cell to the other cell, and then sometimes in MODFLOW and DBT you can have better results. Okay, remember that is a solver. Okay, and this is a solver. Okay, and it's really a great solver. For example, when I do regional modeling, for me, and this is really for me, I use MODFLOW NWT instead of MODFLOW 6 because for me MODFLOW NWT works better. Okay, I reach better solutions and I reach it in less time. Okay, then if you are planning dealing with, for example, if you have a basin that is under high stress and then you have a model that can diagnose the basin in real time, considering irrigation, pumping, transportation, losses on channels, and so on, I will strongly recommend to use the OWHM, one word hydrological model. Okay, that is a model that represents most of the with higher complexity what happens on as a valley scale. Okay, there are few models actually done in this code. Okay, for example, there are more done in this code for some stress aquifers in the US, okay, in Albuquerque and California. They have this model done, and sometimes they have this model connected to a website where in the website you can have the diagnose of the water levels, and then you can apply some groundwater policies that say do not pump if you are under this level. And so yeah, the concept is great, and then you face some governability issues, and you can do that with WHM model. Okay, great. And then we have the CFP. The CFP model is related when you need to work with fluid process. For example, okay, and what is the topic here? In MODFLOW, in a numerical model, in a groundwater flow system like this, it is assumed that the flow is laminar. Okay, so you have a flow alongside the spaces in the pores. I mean, in the spaces on the pore, you have your groundwater flow. Okay, but what will happen if you have a tunnel? Or what will happen if you have a karstic conduit? Then, if you have a tunnel or if you have a karstic conduit, those flow there will be turbulent, okay? Because they might be turbulent because water will reach higher velocities, okay? So Darcy actually do not work with turbulent flow. Darcy work only for laminar flow. It's in fact an approach on the on laminar flow conditions. Okay, so if you want to work together with a tunnel or with a karstic conduit together with the groundwater flow, I will strongly recommend to use MODFLOW CFD. Okay, and then if you want to do a local grid refinement, this can be done better in MODFLOW 6, but if you want to do it with MODFLOW 2005, you can use this one. Okay, if you are here with me, type yes 5. Okay, I think that some people have already gave the cities where they are connecting, but I think that I missed them. So just if you over the chat can see can type the city where you're connecting, it would be nice to yeah. Let's do that. Let's type hello and the city from where you're connecting, so I can see how is hello in your native language. Let's type hello in your native language and the city where you're connected, so I can know more about your language and where you're connected. Okay, so here let's type 20 columns, 30 rows. No, 20 columns, 30 columns, 20 rows, 2 layers of 50 and 50, and this will be sand, and this will be clay, no, lime. This will be called 100, and then we are going to have 40 meters of sand, so it will be 60, and it will be, we will have 50 to 10. Okay. Let's see, from Nicaragua, from hello, with Rotterdam. Hello. From South Africa. Wow. I'm really sorry. I wish I can speak Arabic, but I think that there are some pronunciation that I do not get. From Mozambique, Grenoble, Tanzania, South Africa. Wow. Oh, great to give this. You are the most rich audience that I have, demographically rich audience that I have given any course. Okay. Okay. And there is a great question from Amali that say, what is the set of criteria do you consider when specifying the initial grid? Great question. For example, this is this. I mean, when you define the grids, I mean, when you define the extension, is mostly for the first models that you're going to do. So it's for a local model. So later on, you have this no grid option. Do not press it. But later on, when you see apply cases, you will use shape files, and the shape files actually define the grid. Okay. But since we are doing at the beginning, we only define the grid by ourselves. Which is the criteria to define the grid? This is a strong question, very interesting. Why? Because the size of the criteria is kind of has some engineering. Okay, for example, if you have a basin, somebody can tell you, oh, you have to model this on a grid of 1 meter per square meter because that will bring you good resolution. And they say, okay, that's right. You can have your basin on a grid of 1 meter by 1 meter. However, there is the computational. You have to take into account the computational resources. Okay, the even Model Muse is not designed to work, for example, with grids of 1,000 columns and 1,000 rows, because actually the graphical user interface, and I have tried, will be all blocked. It will be all, how say, which is the word of that one? When you have it all together and very tight among each other. Okay, yeah, you will have it like this. Okay, and for example, you cannot have infinite layers. Why? Because as well you will have a model with a large number of cells. Okay, so actually the grid cell size is defined. I mean, the grid cell size is defined in order that you have an adequate number of cells. For me, in my experience, a number of cells of 500,000. Okay, if you are doing a model, you have 500,000 cells is right. I mean, you don't. I mean, if you can do it with less cells, it's better. But if you have 500,000 cells, yeah, the Model Muse can work with that. You can work with 1 million cells, but then you will see that all the steps actually became to require lots of time. So the workflow is really slow. Yeah. I have also worked with 1 million cells once. Okay. But I won't try, I won't do any model that will be higher than 1 million cells, and I don't even recommend to do any model that is above 500,000 cells. Okay. There is a model where I was working with how many cells? Around 700,000 cells, but I haven't done that in Model Muse. I haven't done that in FlowPy and Python, and it, I was really aware of the resources, and I kept the uh, and I did it in Linux, okay, because I wanted all the power to be dedicated to this process. Okay, so I hope that this answered your question. Okay, so here um, this is something good because you have to remember that in numerical modeling and in that and as well in other models, you don't define the layer thickness. The layer thickness is defined by the interface among the top of the layer and the bottom of the layer. So this is the top. This is model top. Model top. It appears on with the gray background because model top is a variable of Model Muse. Okay, and it's model top with capital M and capital G and underscore. Okay, model top reflects the surface, and the surface in this case is 100 meters. And then it appears the bottom elevation of the first layer. The first layer for us will be sand, and this sand will be the bottom elevation is 60 meters. So then tell me on the chat which will be the thickness of the layer. Okay, on the chat, please write which is the thickness of the layer. Okay, great. It's 40. So you have 40 as the layer thickness. Okay, then we have the line, and the bottom of the line is 10. Okay, So tell me which is the, if the bottom of the sand was 60, and if the bottom of the lime layer is 10 and the sand is above the lime layer, which is the thickness of our lime layer? Okay, 50. Great. So this is how you define the layer thickness, by defining the top and the bottom. Okay, great. So with that, this is to define the origin of the upper left corner. So, and what is the origin of the upper left corner? Because since this is not Cartesian, this is this works as a matrix. Everything starts from this point because rows. Rows. This is the first row, second row, third row, fourth row, and this is the column. First column, second column, third column. So actually you have to define this. This will be your zero. That is not the same as the geospatial zero origin, because this is the geospatial origin, but for the matrix, this is the row, this is the origin. Okay? So in our case will be 1000, 1100. Okay? If you are here with me, type finish and write on the chat yes 6. Okay? If you are here with me, press finish and type on the chat yes 6. Okay, I have questions. Should we take layers from the borehole or your technical data? Sure. Sure, you can insert all your geological model, and there are tutorials for that. Okay? But these are, how to say, if you are, it's like kind of doing the Tour de France if you have not managed to learn how to ride a bicycle. Okay, then Tahira asks, does log helps here for fine? Yes, sure. I mean, there are tutorials about how to implement geological models in MODFLOW. Okay, but the procedure is much advanced and is different for that. Okay, this is a simple model where everybody has its first step in numerical modeling. Okay. There is a, what is significant? This is the size of the column, and this is the cell size, and we will see on the grid. And what if my area difference thickness for the sediment? Okay, this as well, please. This is a very hypothetical model. Then there are different steps where we can define varying layers of varying thickness, or like anticlinals and so on. And there is how do you come back? No, you cannot go back in this. So once you have finished, whether you open Model Muse again, but there is no back here. This set is actually the same as surface. Actually, this set is not doing much on the simulation. Okay. Can you use them? Yes, you can use them for surface elevation, and there are tutorials on our blogs for that. However, in this case, the surface elevation is horizontal. And yes, I have seen that this is buffering a little bit. Yeah, sometimes, I mean, due to the quarantine, our internet service were not that great, but now are not better. So, but okay, be patient. I will see if there is buffering, or you can write. Okay, so finish. Okay, great. So here you have your model that has with this one, we can join, and the model has 20 rows, 30 columns, and this is the aerial view of the model, and this is a cross section on this line, okay, on this line, and this is a cross section on this line, okay. I can do a zoom here, and if you are here with me, type yes 7. If you are here with me, type yes 7. Great. So, okay, so the objective of this class was to show you some of the functionalities of MODFLOW, and then we are going to talk about that. Okay, first of all, the line 1, so the here this is the menu toolbar. Okay, so this is file, edit, grid, data, object, and so on. This is the menu toolbar. No, yeah, this is the menu, and these are the tools toolbar. Okay, so here where you find the tools. This is the view from the top. This is the view from the right side, and this is the view from front. Okay, and then here we have a 3D view. This 3D view is basic, yeah, and here you can add the grid and a grid on the cross section. Okay. Okay, and then you can rotate it with your mouse, and then you can, and with the right click and up and down, you can do zoom as well. Okay, resolution is not the best, but it's really handy when you are dealing with when you want to locate a boundary conditions or to see if something is there. Okay, great. Okay, so let's see. Okay, I will do here. Okay, we have pan with the hand. We can move the our model, and then we can move it well on the cross sections. So just try this, please. Try this. You will see that this coordinate that we have defined as 1000, 1000 is actually this point. Okay, right? And then you will see that some of the lines are more thick than the other ones. Okay, do you see? Okay, do you see that that this line is more thick than the other ones? Okay, and what does it mean? When a line of the grid is thicker than the other ones, it means that it's a multiple of 10. So it means this is my first column, my second column, my third column, 4, 5, 6, 7, 8, 9, 10, and then you have the tick. Okay? And then you have 10, and then you have the tick line. So instead, for example, if somebody asks me which are the number of columns and rows that they have, they say, okay, rows 10 and 10, 20 rows, and columns 10, 10, 10, 30 columns. Okay? Okay, great. Okay, let's see. Let's go ahead. For example, here we are in the first layer, but we can go to the second layer. Okay, with this, if I press here, I can go to the second layer, and then I get to the first layer. Since the first layer and the second layer has the same geometry and hydraulic parameters, nothing will be seen. Okay, and here as well you can do it with the cross sections. Here you will see some changes because if you press here, this you will see actually the cross section in this alignment. Since the geometry is the same, it's nothing that it, I mean you will see the same cross section. But when you are dealing with regional modeling, actually there is a big difference on what you see at every cross section. Okay, great. What else? Then we have this is the ruler, and then we have another ruler here. Okay, so here we have something that, for example, I have say which is my grid space, my cell size is 50 by 50, so I can check this. So this is around 50, great, and this is around 50. So I can tell you that my grid, what I have now, I can tell you that the cell size is actually 50 by 50. Okay, great. And then here you can see the coordinates. What else? And then I can do a zoom here with this one, and then I can do a zoom out with this one, and then this is zoom window. With this I can do zoom tail window, and then I can do zoom out. Okay, so zoom window, zoom in, zoom out, pan, and this is zoom to previous. So what does it mean? So if I have done a zoom here and I want to go to the latest zoom, this is my zoom previous. Okay. Then is a question here. Shouldn't the colors in the vertical views be opposite? I should have two cells in each and the vertical. Wow. Shouldn't the colors in the vertical views? I mean, why? Okay. The green color means this cross section, and the blue color means this cross section. Only the nodes, only the nodes where the cross section, what you are seeing on those cross section. Okay, right. Let's go and let's move. Okay, if you have followed my tutorial, okay, you should have this on your. If you have followed the tutorial of the installation, you should have ended with C, P, and then for example here I have MODFLOW 2005, NWT, and some budget. Okay, maybe for example here I need the MODFLOW, and what I will need is MODFLOW 6, for example. Okay. If you have this folder on your C drive, please type yes 8. If you have this very app folder inside your C drive, please type yes 8. Please type yes 8 if you have this folder, because this folder is if you have finished the tutorial. In other courses, when I asked everybody have MODFLOW installed, and everybody told me yes, because they have Model Muse installed, but this folder is actually the engines that will run Model Muse. Okay, if you don't have it, don't worry. There is the tutorial, but in the tutorial, go till the end of the tutorial, because in the end of the tutorial is where we are going to install this. For example, I know that I don't have the W app completed, because I don't, here in my case, I don't have the MODFLOW 6. So I will do it, and for the people that has already done this a refresh, and for the other people will be the step that you will do after this class. So in model, everybody goes to model and then goes to program locations. Okay, so in model, everybody goes to model, MODFLOW and MODFLOW program locations. Wow, yeah. My advice is to do the complete tutorial, please. Okay, so the complete tutorial will be here on the course to install tutorial to install MODFLOW and Model Muse, and then appear my face, and I will drop this on the chat, and then you will see the WWRD app folder. You have to create it by your own, and then you have to place the files there. Okay, so see till the end of the tutorial, and then you will have a successful tutorial. Okay. So here, for example, I don't have MODFLOW 6. I do not have this. But I have here a link. So what I do is I say, well, I do double click here, and it will redirect me to the MODFLOW 6 website. And I say, okay, I want to download MODFLOW 6 for Microsoft Windows. Okay, yes. Yes, open this, and it will start downloading MODFLOW 6. That is 6.11, that is released on the latest June. Okay. Okay, actually it's downloading. Okay. And it's kind of okay, it will take some time. I can explain some things here. Okay, here it appears some of the MODFLOW options together with some other options for pre and post processing. Okay, so here we have the engine for MODFLOW 6. We have here the engine. For example, here I do have installed MODFLOW 2005. I do not have MODFLOW LGR. I do have MODFLOW NWT. I don't have MODFLOW CFP. I don't have MODFLOW OWHM. And for example, MODPAD. What is MODPAD? MODPAD is a particle tracking model. Okay, so and this is coupled to MODFLOW. What does it mean? That if I have a groundwater model and then I want to see which is the trajectory of any particle, this particle has to MODPAD can simulate the trajectory, the path line of this particle. Okay. Then you have some budget, and what is some budget? If you want to do the water analysis of a certain part of a certain boundary condition or so, you can do it with defining as some budget. Then you have this MT3DMS and MT3D USGS. What is this? This is a transport model that is also coupled to MODFLOW. And MT3MS was done by the University of Alabama, like year 2000, I guess, or maybe I can be wrong. And there is a latest version of the MT3D USGS that is a code developed by the USGS that was released 5 years ago, I guess. Okay. If you want to do some sensibility analysis or automatic parametrization, you can use ModelMate. And then the text editor by default is defined as the notepad, and the model monitor is this one, and this is a utility that will help us when you run a model. Okay, so please tell me which you have MODFLOW 6 installed on your computer. If you have MODFLOW 6 installed on your computer, please type yes 9. Okay. Okay. Hans, are you there?
Yes, I'm there.
Hans, it will be, for say, methodological or pedagogic to have a 10-minute pause here, or like is we go everything in a row. I mean, it's really up to you.
How long do you still have to cover?
The half, because it was, or it was designed for 1 hour.
Okay. I think you can better continue given that people have reserved the time now and their bandwidths.
Okay, okay. Yep. Yeah. Okay, so let's continue. Okay, so because yeah, I will continue with the next step. Oh, okay, so let's continue. Okay, I can install ModFlow 6 later. Okay, so the objectives of the second part is the learning the function of the basic tools. So here we have the five geometries available in in Model Muse. Okay, so this is the point, the line, the polygon. Okay, this is the point, the line, and the polygon. Point, line, and polygon. However, you have these two options that are really close. This is a straight line and a straight polygon. Okay, so what does it mean? That if you do a polygon or a line, for example, I will do, okay, I will do, then you will say, I will do a line because this is more to show you. Okay, let's go. Okay, I will do a line. This is a normal line that you can define anywhere. Yeah? Okay, but however, if I select this, I can do a line, but only parallel to the, for example, okay, I can do only parallel to the axis, okay, to x-axis and y-axis, okay. So this is a line, but this is a line that can be only parallel to the x-axis and to y-axis, okay. So this is the line. Okay, great. And this straight polygon is also polygon, but can be only parallel and it has to be a square. Yeah. Okay, so this is the difference between these two. So actually, those are special conditions of the point, line, and polygon. Okay, great. So uh, we are going to make, I mean, if you are going to select a river, you can do it with lines or polygon. If you, for example, if you are going to create a well, you have to do it with points. If you want to create a polyline, you can do it with, if you want to represent a river, it will be a polyline. And if you want to select a wetland, you can do it with polygon. Okay? So this will be mostly related to points. This will be mostly related to streams. And the other ones will be related to wetlands or to protection zones, or will be related to contaminant sources as well. Okay, this, I mean, we are, you as a modeler, you have many tools, and then you can use the tools in this way, but you can also select the only use for the tool. I mean, there is no, I mean, the software allows you to do that. Okay, so let's create a new line, a new point. So let's create a new point, select this one, and press anywhere in your model, okay, and this window will appear. So if you are here with me, type yes 10. If you are here with me, type yes 10. Okay, let's have a look on the different. Let's have a look on the different conditions here, because it can be that for you have some different names here, but there is no problem. Yeah, but please have a look, and then we are going to review all together. Okay, so here this is the name. The name is actually aleatory, so we can type well, for example. Well. Okay, great. Then what else? Then we have the object order. For example, for me is the first object order. If you have done any object before and then you have deleted, actually you have a you can have this object order actually is the index of all the objects that are on the model. So in this case, we only have one, so it will be one. You can change the color line. Why not? Why not change it? Because by default it's black, and if you leave it in black, actually can be confused with the grid. That's why I always change. Okay, so let's see. And then, for example, you can define as quad-tree refinement. Okay, and this is something that I will explain right now. Okay, so if you are here with me, yeah, type yes 11. If you are here with me, type yes 11. Okay. We are, yeah, I have seen that the course content was designed for 1 hour. We are going to do 15, and then we have already over this 1 hour. But we are going to do 15 minutes more. If Hans, is that correct? Give me your approval.
Fine for me, Saul.
Yeah, okay. Because I don't want that anybody that has to leave this course can be missing something for the other. Okay, and as I thought, as maybe the organization, this link will be available for you to review afterwards. Okay, so let's talk about the number of set formats. Okay, so here we have 0, 1, and 2. And what does it mean? Okay, there are some objects that are not related to elevation. So which are the objects that are not related to elevation? For example, the evapotranspiration that recharge is not related to elevation, it's related to the model itself. Okay, so if you want to define an spatial object that is not related to any elevation, you press this 0. Yeah. But if you want to define, for example, a well screen, or for example, a river location, you have to relate it to one elevation, because the river is located at just at one elevation. Okay, but for example, if you want to define this as, for example, if you have a drilling log, and in the drilling log you have certain material from one elevation to the other elevation, you can define this as two formulas. Okay, so this is how it works. These formulas define the the set direction of your object, okay? In this case, we are going to define that this, since this will be a well, our well will be located 10 meters below surface, okay? So it will be model top minus 10, okay? Let's see, I can type model top minus 10 because my model top is 100 minus 10 will be 90. Or I can type as well 90, it's the same. Yep. So, but I will say model top minus 10. If you are going to work with model top, just remember there has to be model with capital M, underscore, and capital T. Okay? Great. So with that, we have our, and this is the quadrille refinement. The quadrille refinement is actually not being used here because I will tell you where the quadrille refinement is being used. Okay? So far, we are only going to define the object. So I just type OK. And then if I go here to data, not to grid, if I switch to discretize by vertex, okay, if I switch to discretize by vertex, here, there in discretize by vertex that we are not going to do, but there are tutorials on that, we can we can do quadrille refinements. Okay, that is a type of local discretization in MODFLOW. Okay, but we are not going to do that. Okay, so here we have our well, and then we are going to create a river. With this, we create a river that crosses. Yeah, the river crosses the model, and actually, as you can see here, is crossing the model, okay, and then I do double click. I do double click here, and this will be my river. And change color. Okay, and then I just type one formula because for me my river is model top minus 2. Okay, model top minus 2. Okay. Here. So this will be river and this will be model top minus 2. There is an option here that is position lock. And what is this option? Okay, imagine that you have imported your river network. Okay, we're going to see that later where you can import a river network. But imagine that you have imported a river network. Okay, this river network actually is referred to a specific place. You don't need. For example, if I compress position lock, I can change the location of the river because for me, like I say, okay, maybe the river wants like that. But if you port a river network, you don't need this option to be available because you know that the river network is there. Okay, so if, for example, if we don't want that this river network, if we want that this river network won't be changed no matter what you do, we press here position lock. Okay, yeah. This is more on for the quality of your simulations because you can create you can be sure that the objects that you have imported are there. I mean, are in the required position. Okay, so far that's it. And if you have a line, actually the object length will appear here. Okay. And this is my second object, so the object order will be this one. And that is okay. Okay. And then I will create a polygon. And with this, I can create a polygon that is represented a contaminant source or something like that. I can create. To finish, I do double click And then this is the wetland, for example. Wetland. I can change color. I can change the color of the outer part, but the visualization options of Model Muse are really scarce, but there is an option here to define the inside color, the color of the polygon. Okay, and this one will be 3 meters below surface, so it will be at 90 centimeters. Okay, and this won't be position lock because we there are options as well to change the there are options as well to change the position of the points. Okay, and then here, since you are working with them, since you are working with the polygon, you have an area here. Okay. Okay. Everybody's here, please. Yes, 12. Okay. Since this one is not position lock, I can do this. For example, yeah, imagine that I have selected. I can select it, but I can move it. I can move it, okay? And maybe this is, I mean, sometimes this can be required and sometimes that cannot be required on your groundwater model because you know explicitly where is your groundwater, where is your object, okay? But there are other options here. For example, I can move the vertex. I can select the vertex here and I can select the vertex here, okay? And I can select the vertex here as well and here. Okay, I can do small edits on the spot instead of, for example, going back to GIS to QGIS and bringing back the object and doing the edits here. I can do the edits right on Model Muse. Okay, great. So with this, for example, I don't know. For example, I want to see if the river is position locked. I want to see if the river is position locked. I do double click with the red arrow. I select. When you know that it's selected, because the vertex will appear, and then you do double click here, and this appears here, and they say, it's position locked. So actually, I cannot change this. Okay, so far that will be everything for today, and then you were really how to say very mixed and very rich group of attendees, and I'm really happy to have you provided this course, this class. See you on Friday. And there is a question of Farfan Llano that say the river and everything is on the first layer because actually is the objects are defined on the layer that intersect the object. Since all of these are located on the first layer, everything is located in the first layer. Okay. Bueno, in my language say muchas gracias. And Hans, I leave you to say goodbye of this class.
Yeah, Saul, thank you very much. Maybe you want to share your face also
Okay.
to say bye to the attendees.
Let me stop.
Very grateful that you give these free sessions, basically donated to the Open Coursera platform of IHE Delft. So looking very much forward to the next session. I'm learning also a lot from you as a more in the surface water. I now dive into the groundwater with you. Just to take the opportunity, I would like to share some other free stuff that is coming up this week already. So I'm going to share my screen. One moment. So if you go to the IHE Delft website, then you'll find here a link to a webinar on QGIS for preparing and visualizing hydrological data. Already more than 1,000 people have registered. So
Wow.
you can join it for free. It's organized by the Australian Water School, and Kurt Menke, the co-author of our book, will be speaking, and we'll have Saber Rajmoui, who is also working a lot with his company on the link between hydrological models and GIS. And there's Craig Price, who knows a lot about HatariLabs modeling. So definitely nice to join this session. And after the free webinar, you can also register for online courses. Those are paid. Another thing that I want to point out is that our September short courses are now offered online. So maybe you want to check it out. They are not free. We need a balance between, of course, what is free and what is not. But if you want to have a certificate, an official QGIS certificate, for example, and support by Kurt Menke and myself, you can join this course now from 14 to 18 September. Saul, you want to share something?
Yes, well, if you follow me by LinkedIn, you will see that I was very active in Voronoi grids, and I don't know if you are really interested in that. We have an e-learning platform. We have in Spanish as well. We have an e-learning platform in Spanish where we have some kind of diploma that is a joint of many. I will share my screen. Sorry. That where we have some diplomas that are on the group of many courses in numerical modeling, and on next year they will be the first that we are going to provide in English. Okay, and this is related that for some people that want to do like comprehensive, or like they want to have a level where they can do a master thesis or like working in numerical modeling. In English, we have in the diploma in English will be next year, but in Spanish we have been doing like this is the form is long. And there in English we have an online course in groundwatering with MODFLOW and Model Muse. This was a course that was given recently, and there will be a course on MODFLOW and FlowPy soon coming, and there are some webinars of calibration, sensibility analysis, and so on. If you are interested, you can. For example, this one is free, so you create your account and enter this. This one is free as well. This one is paid because you pay through PayPal. Okay, so as well as Hans has said, there is this equilibrium of what is free and what is paid. But just to remind you that everything that we do it because we love what we do, and we do with passion to our courses. So you will see that if you take them. Okay.
That's indeed true, Saul. Great. Okay, I wish everybody a great day, morning, evening, night, wherever you are in the world. For me, it's almost dinner time. Hope to see you all next time and learn a lot more from Saul. In the meantime, check out the OpenCourseware platform and do those classes so you are at the right point when we have our next live sessions. Thank you all. Bye-bye.
See you. Hasta luego. Ciao.